Okay, fellows out there, welcome to lecture 1 module 1 of my video series on introduction to data structures in C. Today we will be talking about concepts of function. We will look into what are built-in functions and how are they available and where are they available in C libraries, and then we will talk into concepts of user-defined functions. Okay, so the standard C library consists of a stack of header files, okay, namely .h files, which can be invoked or called in this. The stdio.io.h header file basically incorporates functionalities such as printf, scanf, fclose, and so on. So as the name implies, these have functionalities which are associated with the standard input output devices of the hardware. Then we have the standard libraries which have functions like random number generation, allocation of dynamic memory using malloc, calloc, and so on. The string header file or string.h header file gives us access to functions such as string concatenation, string comparison, string to string conversion, etc. The time.h library file gives us access to the system time which can be used in our program. Similarly, the math.h gives access to math functions such as sine, cos, tan, and so on. So these are some of the standard library files that we will be using extensively over this course. Coming to user-defined functions. So apart from the standard library functions, the user can or the programmer can basically define his own functions and use them in order to make the function more scalable, portable, and manageable. As already said, by doing so, by using user-defined functions or breaking up your code into smaller functions, avoids rewriting of the code over and over again, making us abide by the concept of don't repeat yourself. Okay. So how do you go about writing a user-defined function? In order to materialize the concept of user-defined function, one has to know these three concepts. One is function declaration, other one is function call, and function definition. Function declaration is very similar to as that of declaring of a user-defined data type. So you declare a data type and you have a prototype of it. So similarly, in function declaration, we basically declare a function and have a prototype in terms of its name, the type of input parameters that it takes in, and the output parameters that it returns. So that forms the function declaration part. Next comes the function call part. So if the user or the programmer wants to call this function or invoke this function, how is the function to be called? What are the parameters to be passed, and how do I get the parameters out of this function or values out of this function? So that falls into the concept of function call. And then we have the most important part, that is function definition. This is the part where you actually define the function or you code the functionality of the function that you intend to create. So let us take it up one by one. Function declaration part. Okay, as already mentioned, the function declaration is very similar to that of a variable declaration. Okay, it basically gives us a gist of the function in terms of its name, the parameters that it can take in, and the return types that is expected out of it. Generally, the function definition part is written as a global declaration on the main program, okay, or above the main program. The general form in which the function is declared is given out here. So first we have a data type, which means to say that what is the type of data the function is going to return. Are we expecting it to return an integer or floating point and so on. Then comes the function name. Okay, how do you basically name this function? How do you invoke it? What do you want to call it? and then comes the parameter list, okay, or the arguments. Okay, so this is where you can have multiple arguments or data that can be passed on to a function. Okay, so that is how a function is being declared, and take care that the declaration is done in the global declaration section or above the main program. That is where generally programs functions are being declared. You can obviously have an header file and put all these things into the header file and then call the header file in the preprocessor directives. That is permissible as well, but as a beginner it's better to basically define them as a global declaration, as a global in the global declaration part above the main program. As said, functions can return values. It can return an integer, a float, or it can return a void, nothing. Okay, so it does have a return type as well. So that is about the function declaration. Next comes the function call. Calling a function in a program is writing the name of the function and passing on the necessary arguments that are required for the function to be functional. Okay, so we can having done that, if the function returns any return type, we can store the return type of the function into a variable, very similar to as that how you assign a data to a variable. So if a function basically returns an integer and you want to store it in an integer variable, say x, so you can always say int x is equal to function1, where the function is taking an input, say x1 comma x2. Okay, so these are the two arguments which are passed on to the function. Okay, and this is the return type which has been stored inside a local variable. You can directly print out the output of the function as well. If you prefer not to store it in a variable, you can basically use printf command and then give the function and invoke the function and print out the variable that you get out of the function or the data that you get out of it. Okay, so the arguments can be basically a single argument, or it can be argument list as given out here. Here I have two arguments which has been passed to a function. So it could have, and each of the argument is been separated by a comma operator. Okay, so that is how you pass data or arguments to a particular function. So that was about function call. Basically, a function can be called in two types. One thing is called by value, other one is called by reference. What is given out here is called by value. So if there is a variable, local variable, say x1, which is equal to 3, and then you have say x2 which is equal to 2, and you want to pass this 3 and 2 into the function, then you just mention it as function1 x1 comma x2. So what actually happens is the value stored in x1 and x2 are passed on inside the function. So that is what is called as call by value, which means to say that you are invoking the function and you are passing some parameter values into this function. So that is call by value. You can obviously use call by reference as well. What is call by reference? Suppose you want to pass on to information to the function, not in terms of its value. You want to pass the memory location where the value is stored. Okay, so you can use the reference operator and and pass on the address of this. So here the values are not passed directly, but what is passed is the address at which this value is stored. Say suppose this value is stored in the address say xx, and this value is stored in the address say yy, and what you want to do is you do not want to pass 3 and 2 directly. You want to pass xx and yy, so that the function can basically have this memory address, look into it and get the value out of this memory address. So that is how values are passed. So we use the reference operator in order to pass the address of this particular variable. Hence this particular type of call is called as call by reference. One uses call by value if you do not want to basically modify the input parameters that you are passing. So say for example you are passing x1 and x2 out here, and you do not want the function to basically modify these two. You want x1 and x2 to stay as it is, irrespective of what happens in the function. So in that particular case, we go in for call by value, because only the values are passed and the variables themselves have no reference inside the function. So it's a kind of data security that it provides. However, if you want to change the values of these two variables when this function is executed and when you come out of this function, then obviously you need to pass the address, and that is where the function can basically peep into the address and change the value out there as per the requirement of the function or the functionality of the function. And when you come back, the values of x and y might change or might not change based on what is happening inside that particular function. So call by reference is used if you want to actually change the values of the variables or the parameters which are being basically passed on into the function. So that's where you use call by value and call by reference. Okay. Next comes the function definition part. The function definition part is where you write the actual functionality of the function. Normally the functions are defined or coded after the main program. So you fellows have already seen how to write a main code. So a function definition is another function where the name of the function is not main, it's something else. That is as per how you have declared it above your main program. So if you have declared a function saying that int fun1 int comma int, then this is a function of name fun1 which takes two integers and return an integer. So in the definition part, you basically have to write say int fun1, and then you need to basically give some name reference variable. You say int a comma int b and so on. Okay, so that is how you define a function, or you write a function. Okay, so similarly as what you have written main programs in my previous video. So that's the definition. Okay, and having done so, you have basically created a function and ready to go out of it. Okay, ready to use it. Okay, so let's have a look at a demo or a code where call by reference and call by value, as well as definition, declaration and calling of the function becomes apparently clear. Look at this piece of code. This is a piece of code where I write a function called as swapx. Okay, and I want to swap the values of this particular two variables which are passed into the function. So I have my standard preprocessor directive which is stdio.h. Then I have my function declaration which is also called as function prototyping. Okay, so because I said that it just creates a prototype, the declaration just creates a prototype, it doesn't allocate memory or do anything like that. Okay, so it's always, declaration is also called as prototyping. Okay, so then I have my function declaration above the main function, and then I have my main function. Okay, in the main function I have two variables of type integers a and b being initialized to 10 and 20 respectively. Okay, and this line of the code actually is the function call. So I call the function. So what does the function do? It expects two integers to be given as two parameters. Okay, and basically it returns nothing. Okay, so that is how I call a function. So I name the function and I pass on two integer values to it. Okay, so the type of call out here is call by value. As you can see, only the value of a and value of b are passed on into the function, and there is no reference operator. And once the function is been called, then after the function finishes its execution, I come back to the main code and then I print the value of b, a and b respectively, and end my main function. Now let's look into what is happening in the function that is being defined out here. Okay, so this is the function definition part below the main program. So the function takes an integer x and y and stores it into another say variable x and y. So mind you, this x and y are different from this x and y. So these are x and y which exist in the main program. Sorry, this a and b. Sorry, it's not x and y. Sorry. So I have two variables a and b of having the values 10 and 20. So these are the variables which exist in the main program. So the value of 10 actually comes and gets stored in x, and the value of 20 gets the value in b, that is 20, comes and gets stored in y. So here I have two variables x and y which get the value of 10 and 20. Then I have a temporary variable t in order to the swap, and then I do the swap. I transfer x to t, y to x, okay, and then t to y. Okay, so I do the swap of the datas between x and y using a temporary variable t, and then I print the value in both x and y. Okay, so basically you expect what to be printed out is 20 and 10 instead of 10 and 20, because x now has the value 20 and y has the value 10. Fine. Again I come back. So once you come back after execution of this, once you come here and once you print the value of a and b, given that only the value of x and y are affected and the value of a and b are the same, so don't expect 20 and 10 to get printed out here. So what gets printed out is just 10 and 20. So even though you have called a swap function and you have swapped the values between x and y, what gets swapped is the values of x and y and not a and b. So the values of a and b are retained as it is, and that is what you print out in this line of code. Okay, so basically if you want to change the value of a and b, okay, then call by value is not a solution, as we had mentioned in my previous slide. So let's now look into call by reference. Okay, so that's what is happening. I have the prototyping, and then I have the function, and then you have the assignment, and then you have the call of the function. Okay, so let's look at what happens in call by reference. Again, in call by reference, see how the function is being prototyped here. Instead of having two integer variables int x and int y, what I have out here are two pointers of type integers, because in call by reference what is passed is an address, and as we know that pointers are used to store address, so I need pointers. However, take into account you need not specify the name of the variable or the name of the pointer out here. It is just a prototyping. I am still not declaring, I'm just declaring it. I am not defining the function. So you just have to prototype what is the type of data that it takes in and what is the type of data it spits out. Okay, here what it takes in is an address, so I need a pointer. What does it pass? An integer address, so I need an integer pointer to store two addresses. So that is what is being prototyped out here. Okay, having done the function prototype, let me look at the function definition. So in the function definition part, I have here is where you need to basically specify the name of the variable. So in this particular case, it is the two pointers that I am basically I do need. So I have int star x and int star y, taking implying that I have two pointers of type integers x and y, and then I have a temporary variable t. Okay, and what I store on t is the value at x or value pointed by x. What is the value pointed by x? What is there in x? X has the address of a. Okay, x has the address of a, so what is there in a is the value pointed by x. Okay, and what is there in a? It is 10. Okay, so t takes 10, and similarly what is the value pointed by x is been replaced by the value pointed by y. What is the value pointed by y? It is basically 20, because y has the address of b. Okay, so y has the address of b, and in the address of b is 20, so value pointed by y is 20. So that is been given by the into the value pointed by x. So what is there in x? Address of a. So the address of a gets the value 20. So that means to say that this 10 gets replaced by 20 in this function, since you are passing by reference, and it is the address that you are pointing to but not the value directly. So similarly after that, what happens out here is whatever is stored in T. So what was stored in T? 10 was stored in T. So 10 gets transferred to the value pointed by Y. So what is there in Y? Y has the address of B, and the value at address of B becomes 10. Okay, so B gets now 10 and A becomes 20. Okay, and after that, if you print out the value at X and value at Y, what you get is 20 comma 10. Okay, fine. Okay, now when you come back to the main program after calling this, okay, when you come back out here and then you again print the value of A and B, as pointed out here, the value at A is now 20, so 20 gets printed out, and the value at B is 10, so 10 gets printed out. Okay, so the swap function out here actually swaps the value between A and B, unlike the call by value function. So call by reference is a very powerful method uh, of passing information into the function. However, make sure that necessary measures are being taken so that the information doesn't get corrupted in the main function. So with great powers come great responsibilities. So this power has to be handled in a very responsible way. So be aware of it. Okay, thank you guys. So that was about built-in functions and user-defined functions. So how you define it, how you declare it, and then how you call it. And basically we talked about call by reference and call by value, and where are these two concepts basically used, what are their advantages and disadvantages, and so on. Hope you enjoyed this lecture. Stay tuned with me for my next lecture on this in this series. Thank you.